Okay, so again, find the intersection points and look at the x coordinate. So x was -3 and 2. This is that same graph. So I posted this yesterday in Google Classroom. You do not have to print this. You can. I am going to write on it. You're more than welcome to just sketch this graph in your notebook though. So if you are going to sketch it in your notebook, you're going to want to go ahead and do that now. Make sure you label these important points. So we can see those are the two intersection points. So for part B, it says to use the resource page, label each graph with its equation and highlight each function. So one of them is y equals 2x squared plus 5x minus 3. And the other equation is y equals x squared plus 4x plus 3. So we know it's these two equations, and we want to kind of figure out which one is which, and there's two different ways to do this. We can look at the y-intercept. So the one I wrote in green has a y-intercept of -3, and then the one I wrote in pink has a y-intercept of +3. Also, the other thing is the a value. The a value for the green one is 2, which means it would be skinnier. And then the a value here is 1, so it would be the wider one. I think the y-intercept's a little bit easier. So again, the pink one has the y-intercept of +3. So that's going to be this one here. So I'm just going to highlight it. And if you have different color highlighters or colored pencils, pens, maybe you do one dashed over it. And again, this one has a y-intercept of -3 and it's skinnier. It's more vertically stretched. So again, the book says, how do you decide which graph matches which? And you can do two things. You can look at the y-intercepts, you can look at the a value, or you could have plugged points in to see which one matches up. So this is 3-67, this is part B. And then this here is part C. So it says use the graph to identify the x values for which 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. So the 2x squared, so we want to know when is this green guy less than or equal to the pink one. So basically, if it's less than, that means it's going to be below it. So we're asking, when is the green one below the pink one? So I don't have colored pencils out. Colored pencils would be nice here. But basically, the green one is below the pink one everywhere in here. Remember, this inequality, it doesn't have any y values in it. So we're just looking at the x coordinates. The graph is just helping us. So we have these boundary points here. This yellow, sorry, it's not showing up very well, but it's the only other highlighter I have. So those are our boundary points. That's, and when we solved it or looked at the graph, we see that's where they intersect. And so again, we're looking where green was below pink, which was everywhere in here. So it's all of this area here. That would all be shaded in here with these boundary points. So for part C, I'll just kind of write it off to the side. Look at where green is below pink, right? So I think the colors help. And if you didn't use green and pink, whatever colors you used, or that equation is below it. When it's less than, it's going to be below it in terms of the Y value, the outputs. That was kind of C and D. This one here is part E. Same idea. These, if you notice, it's the same inequality, but the inequality sign here is flipped. So now we want to know when is green above pink. Essentially, that's what you're asking yourself. Also something to remember, so again, we look at the boundary points, they're the same here, it's the same graphs, but this one doesn't have the or equal to. So this circle is going to be open, and this circle is going to be open. And so here, when it's green above pink, is everywhere this way. And green is above pink from 2 on this way. So here, this is, I should have written it here too also, sorry. When x is less than -3 or x is greater than 2. This one is -3 is less than or equal to x is less than or equal to 2. So when you shade between the boundary points, your x is written in the middle. If you shade out, you have to write them separately. You cannot combine this and make one inequality. It has to be written as 2 separate inequalities because it's 2 separate pieces. All right. Any questions on that one? So we're going to kind of make 3-68 notes. Inequalities in one variable. So 3-68 is, I'm gonna do the work kind of on this right side and then write our notes or our steps on the left side to follow along with. So it's 4 times the absolute value of x plus 1 minus 2 is greater than 6. So when you're solving an inequality with one variable, the first thing you want to do is change it to equals. So this is 4 times the absolute value of x plus 1 minus 2 is equal to 6. Then we're going to solve the equation for the boundary points. So we solve this equation like we would normally. Absolute value equations, remember, before you work with the absolute value, you have to isolate it. So we have to get the absolute value alone. We're going to add 2 first. So 4 times the absolute value of x plus 1 is equal to 8. Divide by 4. The absolute value of x plus 1 is equal to 2. And then remember, for absolute values, if you have the absolute value equals a number, we know the absolute value under my finger could be 2 or it could be negative 2. So we have x plus 1 equals 2 and x plus 1 equals negative 2. Subtract 1, we get x equals 1. Subtract 1, we get x equals negative 3. These are our boundary points that we were looking for. So you want to be careful. These are not your answers. Those are the boundary points when you go to put this on a number line. So that's kind of going to be what step 3 says. Plot the boundary points on the number line. With, and then I'm just going to kind of, that closed circle or open circle. Remember, it's closed here if it has the or equal to, and it's open if it's less than or greater than. So our original inequality was just a greater than. So this tells us it's going to be an open circle. So I just set up a number line. My boundary points are going to be at 1 and negative 3. And my circles are open, again, because it doesn't have or equal to. What that means is if I plugged in 1 to this inequality, it's going to be a false statement. I would have 6 is greater than 6. So after we plot our points, we're going to plug in a number between the boundary points to the original inequality. And if you only have one boundary point, you would just plug in a number to the left or right. It doesn't matter. So plug in a number between the boundary points to the original inequality. 0's in the middle, so I think 0 is an easy point to test. So if we test x equals 0, 4 times the absolute value of 0 plus 1 minus 2 is greater than 6. This is a question. We are testing this. We want to know, is this true or false? So following our order of operations, this becomes 4 times the absolute value of 1 minus 2 is greater than 6. The absolute value of 1 is just 1. So 4 times 1 minus 2 is greater than 6. 4 minus 2 is greater than 6. And we get 2 is greater than 6, which is false. 2 is not greater than 6. So our last step after we test a point is add shading to the number line and write your final answer. So I'm putting that in all caps and underlining it because this part is often missed. People often will just kind of add their shading to their number line and then forget to write your answer. Your answer should be inequalities. So since this was false when we plugged in 0, so right here at 0 was false. That tells us we do not shade in between the points. Everything in between the points would be false. So we're going to shade out this way and out this way. And these would go on forever. So our final answer is x is less than -3 or x is greater than 1. Again, this step is often skipped and people just write it here or they box their boundary points. X doesn't equal -3. Your answer is going to have the -3 and 1 in it from your boundary points, but you have to write them as inequalities. So again, that should have hopefully been a review, but it's probably been a while since you've done one of those. So for 3-69, it says Bert and Ernie are solving the inequality 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. They're looking at the graph in problem 67. So that's the one that was on that resource page. When Bert has an idea, can't we change this into one parabola and solve our inequality that way, he asks. Ernie says, what do you mean? Can't we determine the solutions by looking at the graph of f of x equals x squared plus x minus 6, Bert replies. Where does Bert get that equation? So, if we have 2x squared plus 5x minus 3 equals, I'm writing it as equals. So if we get this equation equal to 0, that's where it's going to come from. So we're just going to show where it comes from here. So he had this. If I subtract x squared, subtract 4x, and add 3. Wait, I copied. Oh, this was a plus 3. I'm sorry. So you want to subtract 3 here. So subtract x squared, subtract 4x, and subtract 3. We get x squared plus x minus 6 equals 0. So that's where Bert's getting that equation from. So they want us to sketch this for part B. So a couple of different ways we can go about doing this. We can factor it. We can do the quadratic formula. So right now, if we go to sketch it, I'm just setting up my axes. The only point we know right away is that it has a y-intercept of -6. That's not the vertex. We can't just kind of use that. That's the only thing we know from here. So if we wanted to sketch this, we would have to either find the vertex, find the x-intercepts. We'd have to go some route. So if I factor this, so I'm just going to write that I factored, I would get x plus 3 times x minus 2 equals 0. So x plus 3 equals 0, x minus 2 equals 0. I would get -3 and +2. Those would be my x-intercepts. Remember, using the quadratic formula or factoring when we're talking about in terms of a graph, those are going to be your x-intercepts. And so from there, we could see in the middle, this would be our line, and it's just a sketch. Our line of symmetry would be right here at -1/2. That's just halfway between those two x-intercepts. So our vertex is somewhere on that line of symmetry. And it goes like that. My right side didn't come out very well, but that's okay. So for part C, the original problem, I'm sorry, I'm trying to like go back and forth from the book, was 2x squared plus 5x minus 3 is less than. So since we changed the equation, we were essentially looking when is x squared plus x minus 6 less than 0. That's what we were looking for. It had the less than, that's what we changed it into. So we want to know, when is this parabola below 0? So it's everywhere from -3 to 2 that it's below 0. So then looking at this parabola, less than is below, 0 is the right side. So when x is between -3 and 2. Everywhere in here, we're below 0. Our parabola dips down. So when you have a problem like this with two quadratics, or two, it could be a quadratic and a linear, it can be two different expressions altogether. You can graph them separately, which is what we did here on this resource page. They were graphed separately, and then you say one is one below the other. Or you can combine them to make one inequality, graph that one, and look when it's below 0 or above 0 if it said greater than. So you have kind of different options if you have a longer inequality like that. We're going to skip part D, just don't want to take too long. All right, and problem 70. Next, Bert and Ernie work on solving this inequality that we did on problem 68. The 4 times the absolute value of x plus 1 minus 2 is greater than 6. But Ernie has the idea of graphing this instead. So let me just write it down again. So it says, what system of equations should they graph? So when you want to solve an inequality by graphing, you want to graph the left side, and it could be an equation also. You want to graph the left side as y equals and the right side as y equals. So we want to graph the equation y equals 4 times the absolute value of x plus 1 minus 2. That's just that whole left side. And then we also want to graph the equation y equals 6. I'm going to count by 1, so I'm not really going to label anything there. So let's see. Y equals 6, that one's a little bit easier. That's just a horizontal line. So you go up to 6, you make your line. So So that's the line or equation y equals 6. Absolute value graphs, so we should know a few different things. We should know it's V-shaped. The locator point or the vertex here is going to be -1, -2. That's my HK values. So -1, -1, -2 is here. And then since A is 4, that tells us it has a slope of 4 in the positive direction. So going to the right. Focus a little bit better. So since A is 4, it has a slope of 4 in the positive direction, going to the right. So the slope of 4 means up 4 over 1, up 4 over 1, up 4 over 1. So that's the right side. And then we know this is the vertex, so it reflects. So it's up 4, left 1, up 4, left 1, essentially. Just goes the other direction. It's got to be symmetric. So to solve this algebraically again, or graphically, we already did algebraically on our notes. We want to know when is the absolute value above the line. So when is this guy, the V, above the line? So we can see it's here and here. That's when the V is above the line. If we just kind of go down, we see that this is when x is -3 and this is when x is 1. Our original problem doesn't have a y in it. So our answer again isn't going to have y in it. Green is above when x is less than -3 or x is greater than 1. So again, to determine that, I was asking when is the V above the line? Okay. And then we have one more problem to do. And we'll do it kind of as notes as well. So hopefully these will be helpful on your test. 3-71 is, sorry, that's the resource page. 2 variable inequalities. So on this one, we have y is greater than or equal to 2x squared plus 5x minus 3. And y is less than x squared plus 4x plus 3. And these are the same equations we had in the same graphs we graphed on that resource page. So it's like, it's going to be those same ones, but we'll do it as if we didn't have those. So the way I would recommend doing this, if you'd want to kind of figure out what these look like to graph them. So I would make tables anytime I have a two variable inequality. Here, I'm going to have x. Then instead of writing y, I'm going to write what I plug it into. 2x squared plus 5x minus 3. I'm going to go from -3 to +3 for x. And then I'm going to make another table for the other one. And I'll leave space to graph it over here. So when you're graphing two variable inequalities, again, I'd make a table, the x-hand column you fill in, and then you kind of plug into whatever it is here. So if I plug in -3, remember order of operations, -3 squared would be 9 times 2 is 18, minus 5 times -3 is 15, so 18 minus 15 minus 3, I get 0. And you're welcome to plug them into your calculator. It's kind of hard. It's kind of hard to do it this way. In class, we would split them up and I'd call on people. So take a minute, try to plug one or two other values into each of these, and then we'll go over them. So hopefully you were able to plug a few of these in just so that you can practice. Again, I am writing what they are here. Before you graph them, so this first one was greater than or equal to. So this one is going to be solid. When it doesn't have the or equal to, this one is going to be dashed. Keep that in mind. So we can plot these points. Yes, Forrest. When I'm done, I will. Okay. So there's the first one. So I plotted those points. And then the other one also there. Remember that second one is going to be dashed. All right, so something kind of like that. I didn't do very well on this left side. We can also see that they intersect here at 215. I didn't make my graph go up to 15, but that gives you an idea there. They do intersect again. They had these two intersection points the same. So to finish this inequalities graph, remember what you want to do is plug in 0, 0 if you can to both. The only time you cannot plug in 0, 0 is if it goes through 0, 0. So if our parabola passed through 0, 0, we couldn't plug in 0, 0. You can't plug in a point on the line or on the parabola. So our first inequality, we would have 0 is greater than or equal to, so we're checking these. This is our test. 2 times 0 squared plus 5 times 0 minus 3. So 0 is greater than or equal to negative 3 is true. That works. So that tells us we shade toward 0, 0, or where 0, 0 is. So this was for the solid one. So since 0, 0 is here, this is the point we're testing. We would shade inside, and I'm doing it very lightly with my pencil. Again, I should have got colored pencils out, but we're inside of the solid parabola. So you don't cross those solid lines. We can cross the dash lines for this one. Plug it into the 0, 0 into the other one as well. Zero is less than 3 is true. So again, we shade towards 0, 0. This is the dashed parabola, and 0, 0 is outside of it. So we're going to shade outside of the dashed parabola. So that would be all of this stuff. And then basically we look at where they overlap. So where both of them were shaded was everywhere in here. So this is where if you had different colored pencils, you would be able to see it a little bit better. I shaded outside of this one, which sometimes people draw them with arrows, and inside of this one. So it gives us this region here. So for absolute value, or not absolute value, I'm sorry, two variable inequalities, your answer is going to be shading. We can't write this with a less than or equal than or greater than or equal to. It's this whole region. Every point in this blue would make both of these equations true. Again, this should mostly be review. It's now with parabolas. Back in Math 1, you do it with lines. So we have seen it before, but now we're kind of adding an extra step with these parabolas. That is it for today. Reminder though, so that's it for our classwork. Reminder, test next week on Thursday in class. Monday we'll be doing our team tests. Just a heads up, the expectation will be that you have your cameras on. So keep that in mind. About half of you did last time with the team test, and thank you. About half or a little more than half did not. But the expectation for the team test and your individual test during class next week is that your camera is on. So I'm giving you a heads up, Monday and Thursday next week, that will be the expectation. This is it on chapter 3, team test. Then we'll do a review and the closure on Tuesday. We will start chapter 4 Wednesday to give you guys a little bit more time to ask homework questions before your test. If you have homework questions today from the week, your homework tonight is like 74 to 80, I think. Don't quote me on that. Look on PowerSchool or Google Classroom. If you have questions, stick around. Otherwise, have a good weekend, and I will see you Monday at 10 a.m.